Good morning, students. Am I audible? Please to respond, okay? Okay. So this is our class of professional elective 3. That is your rural water supply and on-site sanitation system. So in this class, we're going to discuss about basically about water impurity or impurities present in water. Or in other words, you can say we're going to discuss about drinking water quality. So to check the quality, we need to first determine uh, what are the impurities may present in water. I need how to identify the impurity of water. Okay. And before that also, we're going to discuss about how to collect a sample water from any source, whether it is pipe water or river water. What is a proper way of collecting a sample? Okay. Okay. Anybody want to join? Please ask for the last time. Then we can start. Yeah, cheers. There are so many people, so many students are there, but very few participants are now. Please inform all the students for the last time. Okay then, so let's start. Okay. Okay. So, in this class, we're going to discuss about drinking water quality, basically. Fine. So, actually, if I say in nature, so it is not possible to find a pure water. Okay, it's not quite impossible to find pure water, 100% pure water in nature. That means we have to go for quality check of each and every water source. Um, okay. There is some exception also. Spring water, there are some exception. Comparatively, they are pure, but not 100% pure. Okay, since they are when they are get contact with the atmosphere, contact with the outer face of the earth, then some impurity may come into the water. Fine. So even if you consider rainwater, the rainwater as it drops down from the sky, it is pure. Okay, you can consider the rainwater is in pure form. But when it come in contact with surface of earth, okay, or during the travel from the cloud to the surface, during the travel uh, through the earth or through the atmosphere also, we can say it absorbs moisture and absorb dust, okay, or gases from the atmosphere. Fine, it become impure. At the point of the origin of the cloud, it is pure, but when it come out of the cloud, when it travel through the atmosphere and reach the ground, even the rainwater get um, you know not pure, basically. Fine. Okay, wait. I think it's a very basic thing that I'm going to discuss here. Okay, so the particular water, if I consider rainwater again, it further exposed to organic matter on the surface of earth, and by the time it reaches the source of water supply, and it is found to contain various other impurities also. Okay, so if we consider rainwater, it's traveled through the atmosphere, it absorbs gases, dust from the atmosphere, and when it reaches ground or the surface, it may come contact with organic matter, okay, or other bacterial uh, kind of thing. Okay, it become impure. Fine. That means for that we can classify the impurities present in water in three different heads: physical impurities, chemical impurities, and bacteriological impurities. Okay, so if you want to classify the impurities present in water, we can classify the impurities present in water under three head: physical impurities like different particles like suspended particles or soluble particles or dissolved solid. Okay, all these are, or you can say turbidity. Okay, all these things are physical impurities. You can also, I think these things are already have got in fifth semester environmental engineering. Okay, like chemical impurities, we can say different chemicals present in water. Okay, like different gases. Okay, like odor producing gases like H2S, carbon dioxide, all I can say are impurities. And finally bacteriological impurities like all the microorganism or bacteria with disease causing bacteria. These are also considered as a bacteriological impurities, which you cannot see with a naked eye. So finally we can have three type of impurities: physical, chemical, or bacteriological. Fine. So if I give a summary about that, so water is a universal solvent, and in nature it is never totally pure. I already given you these things. So no matter how isolated it is, a form source of contamination, it will always have some chemicals. Okay. Okay, wait. So if I consider groundwater dissolves most of the minerals when it percolates through soil formation. Okay, when groundwater are actually exist within the earth surface. Okay, surrounded by soil, and soil contain minerals. Okay, and when groundwater travel through the soil strata, it also carries the mineral from the soil. Okay, that means we can say different kind of mineral may also be added in water. Maybe some good or some bad. Fine. Okay, wait a second. So if I give a summary of the different impurities present in water, so depending on the nature of impurities, it may be the impurities are classified based on their nature, and they are physical impurities, chemical impurities, and biological or bacteriological impurities. Okay, these classifications are based on their nature. Okay, so if I tell you that under physical impurities, we can have some example like turbidity, like color, taste, odor, temperature, okay, radioactive substance. All these are under your physical impurities. Okay, what I can repeat now: turbidity, color, taste, odor, temperature, and radioactive substances. So these things, I think it is familiar to you. Already got you have got this thing in your last semester, fine. Regarding turbidity, like color, taste, odor, temperature, all these things, you have got this in fifth semester. So it's time to go back to your fifth semester class notes if you have, or you can also go through your the textbook of environmental engineering. Try to go through that part. Okay, even in the last class also I had told you to go through that revision class. Okay, you have to go through by yourself only about turbidity, about color, okay, all these things. Right. So we'll discuss about this different physical impurities in coming lectures. Okay. Till now, now we are going to discuss about how to analyze the water. Fine. So in order to ascertain the quality of water, it is subjected to various tests. Okay. So to find out the quality of water, we have to go through some test, and this particular test is depend on the impurities present in water. So I already told you how that three types of impurities are present: physical, chemical, and bacteriological or biological. Okay. Right. Yeah. So before test, first and foremost things is what? We have to collect the sample. Okay. And there is a way of collecting sample, whether from your the source of water, maybe from tap water or surface water, considering like river, lake, or etc. So before we take up the various tests, it will be necessary to note the precautions which are to be taken while collecting the sample of water to be analyzed. Fine. So we're going to discuss about that, how to collect sample. So in fact, the sampling of water is the most important part of analysis. Okay, sampling is very important. If you're not collecting the sample correctly, okay, whatever the result you are getting from the sample, it is not reflecting the actual scenario of that water. It may not reflect the actual scenario. That means the first and foremost work is to collect the exact amount or exact amount of water through the exact way of sampling. Fine. Okay. The sampling is the most important part of any analysis because the final result obtained, even from the most accurate analysis, will be misleading if the sample on which such analysis is carried out are not representative ones of the liquid to be tested. That means you maybe go through the accurate way of analysis, but if your sample is not correct, the result, whatever the result you are going to find, it is will be valueless. Clear? That means the sampling, the result, the accurate result is based on the sampling, correct sampling of water. So as a matter of fact, it will be ideal to carry out all the analysis immediately after the collection of sample, and quicker the analysis and more representative will be the result of analysis of the liquid at the time of the samples are taken. That means it's better to go for your analysis or laboratory test immediately after collecting the sample. Okay, you should not waste the time. Okay. So basically, we're going to discuss about some precaution that must be taken during while collecting the water sample. So first of all, the water should be collected in bottle, especially with white glass bottle. Okay, having well fitted stopper. That means it's better to uh, take a transparent bottle, even a white glass bottle, or I think you have that glass bottle that is used in laboratory, chemistry lab. Okay, it's better to take a glass bottle around capacity of 2 liter or something like that. Okay, and it should be well fitted stopper. It must have some well fitted stopper. Okay, or you can say airtight stopper. The bottle having holding capacity about 2 liters of water are necessary for chemical analysis. If you're going for a chemical analysis, at least minimum 2 liters water sample must be needed. And if you're going for a bacteriological analysis, bottle with smaller capacities will be sufficient. Okay, because since in case of bacteriological analysis, we go for microscopic view or different approaches are there. So we don't need huge amount of sample. It's some small amount of sample. It's also be enough. Next, so before using the bottle, it should be thoroughly cleaned. Okay, wait a second. Okay, so bottle must be thoroughly cleaned from inside. Fine. It's better to take uh, directly from the laboratory. The bottle which are actually used in laboratory, it's better to use that bottle. Next, when a sample of water is to be collected from pipe, okay, the water tap must be turned on and the water should be allowed to go waste for at least 2 minutes. That means suppose you are going for collecting a water sample from a tap, municipality tap or any tap, okay. So you have to ignore the first amount of water coming from the tap. At least you have to remain switch on the tap for 2 minutes. Okay, so we are not going to consider that sample from that initial part of the water because it may contain some impurities. Okay, that means to prevent the entry of impurities from the pipe into that your bottle, laboratory testing bottle. So we have to left 2 minutes of flow water. Okay, after that you can go for collecting the sample. And if the water sample is collecting for the bacteriological analysis, the nozzle of the tap should be flame. That means a fire should be done for heating purpose. You have to heat the tap. Okay, and after that, you have to make the tap hot, unbearable hot, and then cool it by running water before the bottle is filled. That means you have to first fire the tap, make it little disinfected, okay, with the heat, then cool it by running water, and after some time you collect the sample. Okay, if your that sample is going for the bacteriological analysis. Next, if you are going to collect sample from lake, that means surface water, lake, streams, river, or spring, even from well, the whole bottle with stopper closed should be immersed deep into the surface of water, and then only the stopper of the bottle should be removed by means of a clean piece of string, and the bottle is filled. Got it? That means suppose you want to collect, for example, suppose you want to collect sample water sample from a river. Okay, so what is the proper way of collecting sample? You have to first uh, take the bottle with the stopper, uh, or you can say the with the lid. You can say airtight lid of the bottle closed, matlab, highly close the bottle and keep the bottle deep inside the surface of the water, deep inside into the water, and then with the thread or by any means you take out the stopper. and allow the water to go into the bottle. Okay, so what is the benefit of doing this kind of procedure? Okay, it will register as entry of floating materials. Fine. That means thus the entry of floating materials will be prevented into the bottle. Fine. So now after collecting the sample, the stopper of bottle should well secured and bottle containing samples of water should be labeled stating the source, date, time of collection. That means after collecting the sample, you have to label it. Label it means label the bottle by mentioning the source of water, the date of collection, date and type of collection. Okay, this is must be labeled around the bottle. Okay, for your record purposes. Fine. So this is all about the basic idea about how to collect your water sample from any water source, like you can say that tap water or surface water. It may be river, lake, or stream, or even well. Got it? So uh, next, next we discuss about some physical characteristics. Okay. So we already discussed some physical characteristics, you know, like turbidity, color, taste, and odor, temperature, isn't it? All these things are represented as physical characteristics or physical impurities, you can say, of impurities of water. Fine. So basically, what is turbidity? These things already you got these things in last semesters. Anyway, I'll just repeat for your as a revision part. So basically, turbidity is what? Turbidity of water indicates presence of suspended or colloidal insoluble matter, including coarse particle like clay, sand, sediment, mud, silt, etc. that settle rapidly on standing. That means you know these things that different particles may present in water, suspended, settleable, or dissolved. Okay, so basically, turbidity represents the suspended particles present in water. Okay, suspended particle it may be contained like clay, sand, silt. Okay, these things may be present in water. Okay, in some cases, of different salts of different that means salts of different components are also represent the you know turbidity of water. Fine, and these colloidal substances and salts may also injurious to health. So this suspended particle may not be present in water, and there is some range. So if I give you the range, the turbidity of feed water or drinking water should not exceed 5 ppm part per million. So this suspended material can be removed by what? By settling, coagulation, and filtration. Okay. So if a large amount of suspended solids are present in water, it will appear turbid in appearance. Turbid means what? You cannot see clearly into the water. If water is not clear, okay, if you the basic example how to uh, know whether that water is turbid or not. So we have to check whether a ray of water can travel through a water sample or not. Okay, if the water is containing suspended solid, okay, the ray of what ray of any ray we can say the ray will not pass through the suspended solid. So um, if you put a source of rays at one point, okay, and if you are observing from the opposite side, and if you can see the light clearly, that means you can say there is no disturbance or there is no resistance. That means there is no presence of suspended solids. That means you can see the light clearly from the opposite side. But if you can't see the light clearly, Okay, that means if the energy at the entry and the energy at the output is different, that means we cannot see clearly the light from the opposite side. That means the light is absorbed or reflected by the suspended solid present there. That means you can say the water is turbidity. Okay, the water is sample is turbidity. Okay, there is a turbidity, but how much percentage of turbidity are there? There is a procedure or there is a method that you can follow to find out the turbidity. So there are different method like Jackson turbidity method is there, Nephelometer is there. Okay, these things are already you have got these things. So you have to go through the same thing again. Okay, it will be good for you. These things also under this syllabus also about turbidity. Okay, you have to know what is turbidity. Okay, and that ppm means what? Part per million. Okay, and different units are there for determination of or for the measurement of turbidity like silica scale. Okay, then Jackson turbidity unit, that is JTU. Okay, and there is one more thing is there, NTU, that is Nephelometric turbidity unit. Okay, so these things you have to know. Okay, the turbidity depends upon the fineness and concentration of particles present in water, that I already told you. That means if more suspended particles are present in water, then you can say the water is more turbid. Fine. So originally turbidity was determined by measuring the depth of light column required to cause the image of the candle flame at the bottom to diffuse into the uniform glow. That means if you are putting one candle below, suppose you are taking a water sample in a transparent glass beaker, okay, in a tripod stand, and from the bottom, if you lighted that one candle, and you can see from the top side whether the light of the candle is visible or not clearly. Okay, these things you can go measuring. So this was measured by Jackson candle turbidity meter. Okay, so whatever the process or procedure I have mentioned now, this is known as Jackson candle turbidity meter. I hope these things are already known to you. Fine. The depth of the sample in the tube, that means the Jackson turbidity tube, was read against the part per million silica scale with 1 ppm of suspended silica called one Jackson turbidity unit. So this is also very important term, Jackson turbidity unit. Okay, so you have to go through these things also, Jackson turbidity unit. So if you want, I can also explain this, but not now. If you need, then I will explain it, these things. Okay, but anyway, these things I think you have the notes for last semester. Go through the notes. If you can't understand, if you have any doubt about that, any method, Jackson turbidity method or Nephelometer, then we can go for a special class for that also, no problem. But for that, before that, it's up. I'm giving you your work is to go through this physical impurities like turbidity, color, odor, all these things, how to determine these things. Okay, you have to go through by yourself. Fine. So nowadays, this turbidity is measured by applying nephelometry or nephelometer, using nephelometer. And the unit of nephelometer used nephelometric turbidity unit. Okay. And the range of nephelometric turbidity unit for our drinking water is 10 to 25 NTU. That means if you're using nephelometer or nephelometric method or nephelometric technique for checking turbidity, the turbidity must be within the range between 10 to 25 NTU. NTU means nephelometric turbidity unit. Okay? Okay, I'll share the screen now. Okay, let me check. Here you can see. So, what is nephelometric technique? Here in nephelometric technique, a light was scattered by particles at right angles to the incident light beam. So there is a system. There is a apparatus where a light source is there fitted within the apparatus, and the light was scattered. Okay, and the scattered light level is proportional to the particle concentration of the sample. That means light was directly concentrated to a water sample. Okay, and the light source coming on the water sample, which is in a testing tube. Okay, the water is scattered from the water sample, and that scattering of light is done because of the presence of the suspended solid present in water. Okay, and the range of turbidity for drinking water is from 10 to 25 NTU. Okay, so these things you have to know this thing. So if I say, tell you about color, you can say, this thing water is colorless. That means if you see some color in water, that means it must contain some chemicals or any different uh, dissolved components are there. Okay, so you can also identify the range of uh, the particular no impurities present in water, and it is measured in cobalt unit. Okay, you have to remember this. The color is measured in cobalt unit. Fine. So the for treated water, for drinking water, the range of color, okay, color causing material or color causing impurities must be within this within this range, that is 5 to 25 cobalt unit. Okay, why it's called cobalt unit? These things you have these things also you have to know. Okay, same thing. If you go to the first your class notes, if you can't understand, you just come to me, I'll explain it. Then after that, again, taste and odor, and this should be also be inspect before drinking. Okay, it should be odorless, and taste, okay, taste should be good, not bad. This odor depend on the contact of stimulating substances with appreciated human receptor cell. Okay, so even here also taste and odor also we can go for different experiment to determine the quality of water depending on taste and odor. You just go through this. Okay, similarly, even temperature is also considered as the physical uh, parameter of water. Okay, so these things you have to go through by yourself for now. Okay, these things are basic things of water quality. Fine. So if you need, just tell me, I'll take your special class for that. Okay, I believe you can get these things very easily and not that tough. Fine. So this is all about today class. We have discussed about different impurities present in water. Fine, like physical, chemical, and bacteriological or biological. And we have discussed about how to go through collecting the sample, collecting the sample. Okay, and also we have discussed about these physical parameters of water. Okay. Okay. Wait. Okay, clear. So I'll just stop my recording now here. Okay. After that, I'll just take your attendance now. Fine. Okay. Okay. I'm just closing my recording.